This video discusses how to find the degree of a polynomial function. We'll start with the definition of a polynomial function. Let n be a non-negative integer and let a sub n minus 1, a sub 2, a sub 1, a sub 0 be real numbers with a sub n not equal to 0. The function f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus a sub 2 times x squared plus a sub 1 times x plus a sub 0 is called a polynomial function of f of x with degree n. The coefficient a sub n is called the leading coefficient. So that definition seems pretty complicated. Basically, a polynomial function is simply a polynomial with f of x in front of it. Let's start by identifying the degree of the polynomial f of x equals 7 plus 5x to the third plus x to the fourth minus 4x to the sixth. Since our polynomial is all multiplied out, the degree of the polynomial function will be the highest number that we see on any variable. This polynomial function is not written in descending order. It may be helpful for you to rewrite it in descending order. And then we look for the highest exponent we see on any term. That highest exponent is 6. If you rewrite the polynomial in descending order, it will be the degree of the leading term. So the degree here is 6. Our next example looks a little bit different. G of x equals 3x to the 8th times x minus 2 squared times x plus 1 cubed. You'll notice this polynomial function is in factored form. Let's expand it into general form to help us identify the degree. So this will be g of x equals 3x to the 8th. Then we'll have 2 factors of x minus 2 and 3 factors of x plus 1. We're going to multiply this all out. I'm going to do it kind of generally and not be real specific in multiplying it out, since what we're most concerned about is the degree. So if I take these last two polynomials and last two factors and multiply it out, we get x squared and then some additional terms. Multiplying out the two factors x minus 2 and x plus 1, again, I'm going to get a quadratic. Continuing to multiply out, if I multiply these two quadratics together, I'm going to get a polynomial that is 4th degree. Multiplying that 4th degree factor with x minus 2, well, that's going to give us something that's 5th degree. And lastly, distributing the 3x to the 8th, that'll give me g of x equal to 3x to the 13th, and then some additional terms after that. The degree of the leading term is equal to 13. The degree of our polynomial is 13. Now, nobody wants to do all that every time we're trying to identify the degree of a polynomial function that's in factored form, so let's see if we can see a shortcut. Look at the powers on our original g of x in factored form, and then look at the degree. of 13 that we got. What's the shortcut? When our polynomial is in factored form, we want to add all the exponents. Eight plus 2 plus 3 gives us our degree of 13.